You're live now?
Yes.
Yeah. Okay. Thank you so much. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everybody. Welcome to another session here in Riyadh Java User Group. We have today another program, another talk, another session. We have here special guests. We have brother Ahmed Misbah and Khalid Najjar. How are you guys?
Hello, Muad.
Hello, thank you. Thank you so much for joining us. Little introduction about Riyadh Java User Group. Here, Riyadh Java User Group, we organize session talks, seminars, conferences, but not yet conferences, but hopefully in the future, with the Java-related topics, especially in software engineering, software architecture, and we host worldwide speakers. Any speaker in the world, most welcome to join us. We are actually actively on YouTube at Riyadh Jag, also Twitter, Riyadh Jag, as well as you can email us riyadhjag@gmail.com. So let's go today with our speakers, and they are going to talk about TDD for Java developers, fundamentals, and must-known libraries. Ahmed Misbah, he is a well-known speaker, actively in the LinkedIn, talking about software architecture and software engineering as well. And we have also, they are working and managing a tech cafe. I will leave it also for the speakers to introduce themselves. Also, we have a great software engineer, Khalid Najjar. Today, we are really, really excited with this topic, guys. The stage is yours, please.
Thank you so much, Muad. Hello, everyone. I'm Ahmed Misbah, and I'm beyond excited to welcome you to the special session streaming live on LinkedIn and YouTube with Tech Cafe and the Riyadh Java User Group. It's a pleasure to be here today alongside my good friend Khalid Al-Naggar. This is a landmark moment for us as it marks the first ever joint session between Tech Cafe and the Riyadh Java User Group since we announced our partnership back in July. We are thrilled to dive into test-driven development for Java developers today, but this is just the beginning. We hope this session will be the first of many as we continue to strengthen our partnership with even more exciting events in the future. So without further ado, let's jump right in and get started. So yeah, today we're talking about TDD for Java developers, fundamentals, and must-know libraries. So let me introduce myself. I'm Ahmed Misbah, founder, chief architect, coach, and instructor at Tech Cafe. I used to be a speaker at the Java Developer Conference in Cairo in 2012 and 2013, back when the Egyptian Java user group was active. I also gave the first joint session between the Google user group and EGJUG back in the same period in 2012 and 2013. I'm also a speaker at the DevOps Days Cairo conference, DroidCon, the Google Developer Group, the Software Engineering Competence Center, Africa and Middle East Conference on Software Engineering, Delta Technopreneurs, and Orange DevTest Days. I have 2 decades of software development experience. I've delivered 2 award-winning innovative solutions, winner of the Dell Hacktrick 2022 UI/UX track. I'm currently a PhD candidate, and I have a master's degree in machine learning and many other professional certifications. And please allow me to introduce my friend and partner, Khalid Al-Naggar, who's a software engineer and instructor speaker at Tech Cafe. He's an expert in test-driven development, behavior-driven development, refactoring, and legacy code. He's also a speaker at the Orange DevTest Days. He also delivered an award-winning innovative solution and winner of the Dell Hacktrick 2022 UI/UX track. So, as I've mentioned in our introduction back in July, the Riyadh Java User Group and Tech Cafe announced their partnerships, and this is the first joint session between our two groups, and we hope that we host more exciting events in the future. So, what do we have prepared for you today? So, we're going to first introduce what test-driven development is. Then, we're going to talk about why TDD matters, why it is important, what is the expected benefits and return on investment from practicing test-driven development. Then, we have prepared the demo for you, applying the full TDD cycle using Java and JUnit. And then after that, we're going to be talking about some TDD practices and their corresponding tools in Java. So let's get started. So what is TDD? I always like to start with Martin Fowler's definition. So Martin Fowler describes TDD as a technique for building software that guides software development by writing tests. It was developed by Kent Beck in the late 1990s as part of extreme programming. And what I like about this definition is that it describes TDD for what it really is. It is a technique for building software, not just for testing software. So you can consider it as a complete software development process for developing and delivering high quality software. So what is the history of test-driven development? Ken Beck describes the story of him rediscovering TDD. Ken Beck doesn't like saying that he invented TDD. He likes saying that he rediscovered TDD. So in this very, very old post on Quora, back when Ken Beck used to work at Facebook, he's saying that TDD goes back to when programming was done on punch cards and ticker tape. And he's saying that he read in some ancient book about programming that this is how programming started. It started by first writing down the expected results on punch cards and then writing the actual code. And then when you would deliver the code to the operator of the mainframe computer, and then you get the output in a few days and then in a basket, you can compare that output with what you've written previously as the expected result, and you would know if things were going right or wrong. And this goes back when programming was done, when there were not yet screens that programmers could use when they were programming. And this goes back to when there were no personal computers. And the practice is so old it goes back to 1958 in Project Mercury, which was the United States' first manned spacecraft program. So the team that was writing software for the space program, they, as we've said, they basically wrote the actual or the expected results on punch cards, and then they would compare the actual results with the expected results on punch cards to see if things were going as expected or not. So this team, which is one of the earliest software development teams, used an early form of test-driven development in the Mercury space program. And yeah, you can read all about it in this slide in front of us. So they're saying that the Project Mercury ran with very short iterations that were time boxed. Sounds very familiar, right? Agile software development methodologies. The development team conducted technical review of all the changes. Interestingly, applied the extreme programming practices of test-driven development, planning, and writing tests before each micro increment. They also practiced top-down development with stubs. So it's nice to see that when software development projects started in the late 50s, it actually started with incremental and iterative methods using what we know today as extreme programming practices. And it's funny to mention that the first paper that described what we know today as the waterfall model was published by Winston Royce in 1970. So after more than 10 years, software development projects started to move to waterfall or linear or sequential processes rather than how they started with incremental and iterative processes with delivering micro increments and using what we know today as technical excellence or XP technical practices. Okay, so how do we practice TDD? What is the TDD cycle? So let's see what Martin Fowler says about this. So he's saying that in essence, you follow 3 simple steps repeatedly. You write a test for the next bit of functionality you want to add. You write the functional code until the test passes. Then you refactor both new and old code to make it well structured. So basically, write a failing test, write just enough code to make the test pass, and then refactor the code you've written and any other code you see in order to commit it in a better form into source control. So basically, this third step is an application of the Boy Scout. Kent Beck summarizes this TDD cycle in the red-green refactor mantra. So in the red bar or the red phase, you write a failing test. Then you write just enough code to make it go green. So that's the green phase. And then you start refactoring, you start cleaning up the smells, applying design principles, writing the actual code, and then you pick up another test and start the cycle all over again. And you keep on picking test case after test case until you've fully developed the feature you want to develop. And the nice thing about this cycle is that it promotes incremental and evolutionary design, because with every test case you pull, the feature evolves until it reaches the state where you consider it done. So is that it? Is it only red-green refactor? No. There is a much, I would say, not much, but a little bit of a longer cycle. So you still have red-green refactor, but you've got the think phase, which is from another cycle by James Shore. So the think phase is basically where you pick up the user story, start analyzing it, and start writing your test list. And after the refactor phase, you've got the integrate phase, and this is part of the 4-beat cycle that was proposed by Mike Hill, and what industrial logic likes to call micro tests. So in the integrate phase, you basically commit your code to version control after each cycle so that it would trigger your CI/CD pipeline. So yeah, it's exactly the same red-green refactor cycle, but with 2 extra phases. And there's this circle in the middle. the values, the principles, and the measures. So everything you do in every phase is guided by the values of TDD, its principles and measures, to make sure that the practice is efficient and is delivering value. Now, we like to call this the Tech Cafe cycle, okay, because it basically combines James Shore's cycle with the 4-beat cycle, and has the values, principles, and measures as guidance in the middle. So now that we have defined what TDD is, we've talked a little bit about its history, and now that we have an idea about the TDD cycle, let's talk about some myths about TDD. So the first myth is that TDD is a testing technique. Alan Hulop comments on that by saying that test-driven development is test-driven development. It's not a testing technique. It's a design and development technique with an emphasis on design. And yes, you get a nice set of essential micro tests, but that's just a nice side effect. So it's not a testing technique, it's a complete software development process. The second myth is that it slows down the team. And here I quote Bob Martin saying, "Would you rather test first or debug later?" Teams who don't apply test-driven development or test-first approaches spend the time they would be writing the tests and executing the red-green refactor cycle instead on debugging. So you're going to be spending that time anyway. So would you rather spend it on writing tests so that you would make sure that you're writing code that delivers the behavior and is well structured? Or would you rather not do all of this and just start writing the code and then go into long debugging sessions? What do you prefer? Bob Martin also says, if you're good at the debugger, it means you've spent a lot of time debugging. I don't want you to be good at the debugger. And this makes perfect sense. If you are using the debugger really well, you've earned this skill because you've used it a lot. So there is a lot of time being wasted here on the debugger. So why waste it on the debugger and not use that time instead to build a safety net for your code base, and actually following a practice or a process that will let you deliver valuable and well-structured code? So TDD actually does not waste time. It actually saves time. In an article that was published on Martin Fowler's website titled Design Stamina Hypothesis, there's this interesting graph. And we see here that if we are doing good design, our productivity, or not the productivity actually, the cumulative functionality, the amount of functionality that you add incrementally to your software is linear. On the other hand, if you don't apply good design by following a process that forces you to do good design, like TDD, okay, you're going to start off a little bit faster than when you are applying a process like TDD or a practice like TDD. However, at a certain point, which we call the design payoff line, the productivity is going to drop, and you're going to start seeing the team adding less functionality because of the accumulation in technical debt. So, okay, you might be starting a little bit slower with good design that is enforced by TDD, but soon applying good design is going to make you move faster than when you're not applying good design. And here I quote Paige Watson from one of our episodes on Tech Cafe. He says, I don't understand why, and he was referring to software companies or teams, have time to write the tests afterwards, but not before. It's the same time, and in fact, it's faster when you get good at it. So Paige Watson is saying that you actually go faster when you're doing test first using TDD or similar approaches than doing test last or not doing test at all. And coming from a guy like Paige Watson, it means a lot. He's a very experienced guy and he knows his craft, he knows his trade. And coming from Bob Martin and Martin Fowler, these guys have decades of experience, so they definitely know what they're talking about. The third and last myth we're going to talk about today is that TDD is unit testing. So whenever you say, let's do TDD, everyone goes like, okay, so you want me to write unit tests. This is completely inaccurate. TDD and test first approaches, which are the cornerstone of actual testing, they cover all test types. And following the test automation pyramid and the agile testing quadrants, you will see that you can apply TDD not just at unit test level, but also at component tests, integration tests, API tests, and beyond. You can also apply it to other types of testing. You can write your performance tests first. You can write your security tests first, and then write the production code that would satisfy these tests. So TDD is not only about unit testing, it's about unit testing, and it's about other test levels and test types. And the test automation pyramid and the agile testing quadrants are testament to that. And we have a concept in test-driven development that is known as test boundaries. So when you're writing an application and you're following some sort of layered architecture, and the example we see here in front of us, this application is using a clean architecture, which is a variation of hexagonal architecture. So we can see that we have a front end, which is an application that runs on the browser, a single page application. And then you've got your back end written using clean architecture. So you've got the API or the controller layer, you've got your use cases, and you've got your core or your domain or your entities. And then you have external dependencies, a database, and perhaps another web service. And of course, your application talks to these external dependencies using ports and adapters. So how do I apply TDD in such a complicated architecture? So you follow the test boundaries. You write unit tests with these boundaries in mind. So unit tests cover either a single method or a single class, and you basically use test doubles to fake or mock or whatever its collaborators, or you write what we know as big unit tests. Okay, so If it's a collaborator, you just test it with whatever unit you're testing. But if it's an external dependency, you don't test that. And then you've got the integration tests where you're basically testing your adapters and the external dependencies they talk to. And you can test your driven side or your driver side. So you can also write tests that would execute against your APIs or your controllers. You can also write through API tests. So these are tests that test your APIs and they cut through the rest of the layers and components of your application or your architecture. And you've got the end-to-end GUI tests, which are at the top or peak of the test automation pyramid. And you shouldn't be writing a lot of those. In fact, some people advise against those. They're saying that they're too expensive, they're too slow, and they're too brittle. So you're basically better off without them, okay? You are better off with the other test levels. So yeah, TDD is not only about unit testing. As you can see, you can actually use TDD to write tests at other levels. And we haven't mentioned the test types, but I think you can imagine from here how you can apply TDD to other test types like performance tests and security tests. And yeah, so I was actually mistaken. This was not the last myth. This is actually the last myth. So TDD is test first development or test last development. So I have the option to write my tests before I write the production code, or I can write them after I write the production code. This is an anti-pattern and a very bad misconception. No, TDD is only about test first. It's not about test last. And there are many, many reasons why you would want to not do test after development or test last development. And you can see here in the slides from an article written by Tim Oettinger and Jeff Langer, you see many, many reasons why not to go for test after development. So it's actually an anti-pattern. And if you go through the classic book, Test-Driven Development by Example by Kent Beck, you will see that one of the patterns of test-driven development is test first. So here, Kent Beck is emphasizing on the fact that TDD is a test first approach. And if you do it test last, it's actually no good. So there you have it. 4 myths about test-driven development. It's not a testing technique. It's actually a development and design technique. It's not only about unit tests. It's about other test levels and test types. It's test first and not test last. And it actually makes the team faster and not slower. Okay, so now that we are done with what TDD is, let's talk about why development teams and developers should be practicing TDD. So TDD has many, many benefits. It promotes better collaboration between all team members because developers, when they start with TDD, developers are not very good at writing a test list. Okay, they're not very talented at that, at least at the beginning. But you've got the testers who are really good at that. So TDD promotes that testers and developers work together using what we know as collaborative programming or the collaborative development. So when we're doing TDD and I'm a developer and I realize that, hey, I need the help of the tester. So it's actually promoting better collaboration. And when you've got the team collaborating together, you've got better collective ownership because we are all working on the same thing together. Collaboration makes work more fun. And as we've said previously, TDD is a development and design technique. So it helps you produce better software designs and higher code quality. With good design, you've got ease of change, which is either the primary or secondary value of software. It promotes continuous testing because you run your test suite in every TDD cycle. As we've seen, it's think, red, green, refactor, integrate. So every time you push your code with the tests to source control, this allows the tests to run again on your CI server and thus promotes continuous testing. It gives you more courage to make changes and deploy. And this is actually one of the principles from Ken Beck's test desiderata. Studies have shown that teams practicing TDD have less defects because TDD is an application of Pokayok or fault-proof design. TDD helps you to use the debugger less and put the time in something that is more useful, and that is the tests and the refactoring. TDD promotes faster feedback. Agile software development is all about sooner feedback. Extreme programming has the concept of feedback loops, which we can see here on the right. So we can see that with doing unit testing, you get feedback every few minutes because it tells you if your tests are passing or not. So you get that feedback every few minutes from the tests. You get a more reliable solution. You've got detailed code documentation because you use naming patterns for the tests and you use arrange, act, assert, which we will talk about later. The tests generally act as documentation for your code. And let's say you want to understand how a piece of code works in terms of behavior. If you start with the tests, this is all the documentation you need. And last but not least, TDD saves project costs in the long run. So based on studies that I have read, TDD takes 15 to 35% more time in active development mode, but it reduces bugs up to 90%. So this added effort in writing the tests first and the continuous refactoring actually saves a lot of time that is going to be wasted later on fixing the bugs that come after testing the code. So what is the return on investment from all of this? You've got the reduced cost of change and faster delivery, and hence a leaner product or project. You get better customer satisfaction because you're delivering sooner with excellent quality. You've got better employee or developer satisfaction. As we've said, TDD makes work more fun. It promotes collaboration. And when the team is delivering software sooner and with the customers happy, this helps the team also be happy. And when the team is practicing technical excellence, this increases the level of satisfaction within the team. And last but not least, TDD allows for reduced risk. And Ken Beck talks about that. When defects appear, it has direct and indirect costs. The direct costs are the cost of fixing the defects, but the indirect costs are the bad relationship you're going to be developing with your customer and your end users. And if this happens a lot, you can lose your business. And so TDD helps you reduce the risk of all of that. And I quote Edwards Deming. He says, inspection to improve quality is too late, ineffective, and costly. Quality comes not from inspection, but from the improvement of the production process. So this is a great reason or enough reason for you to practice TDD, because TDD is not an inspection. It's building quality in the product with writing the tests first and continuous refactoring. I also quote Mary Popendick, the author of Lean Software Development. She says, inspection to find defects is waste. Inspection to prevent defects is essential. If you remember back in the ROI slide, we've said that TDD allows for a leaner project or product. And lean is all about maximizing value and minimizing waste. So if test loss is actually waste and defects are waste, then definitely something opposite that is going to be of value. And this is what TDD is all about. It's a process that helps you prevent defects and not inspect for or detect effects after we have delivered the production code. So there you have it. We have described what TDD is and why you should be practicing TDD. So now I leave the floor to my friend Khaled, who will now show you a hands-on demo on practicing TDD with the Tech Cafe TDD cycle using Java and JUnit. So Khaled, the floor is all yours.
Thank you, Ahmed. Yes, so this is where we are. We will start the demo. The demo is about a Carter, the employee report Carter. You can find it on codingdojo.com. It's a simple exercise to practice TDD. So basically, you're building an employee management system for a local grocery store. The owner wants to know which employees are who are over 18 years so that they could work on Sundays. Uh, and this is the list of his current employees. It's a simple exercise. So we start the TDD cycle with the thinking phase, as Misbah showed. It's about collaboration. It's about figuring out what we're going to test. It's about coming up with a test list. So, but first, let me read the first task in the Carter. The first task, we have made it into a card. The card says, as a shop owner, I want to view a list of all employees who are 18 years or older so that I know who is allowed to work on Sundays. This is the front of the card. On the back, we have the acceptance criteria. That is, we want to return only employees who are 18 years or older. As we said, through collaboration, through brainstorming, through writing down the test list, we can come up with a test list such as this one. Through systematic ways and systematic test design techniques, you can learn more about this Carter and about the test design techniques, etc., in a session that we made in Tech Cafe about learning TDD with TDD cards. You can refer to that to know the details of how we came up with such a list. And then we can do some sorting or prioritizing on that test list, because once you come up with many testers with many elements in a test list, you get to prioritize them and choose the most appropriate one to start with. So in our case, we chose this test to start with. It says when the employee list, the current list of employees, has different age partitions, it should return a list of employees who are 18 years or above. So we can go ahead and start writing the test. to, in the red phase, we can start writing the test to make sure it goes red. So let me get back to the IDE. Here, as you can see, we have a simple class that's called employee. It has only two fields, the name and an age, and then all the other helpful methods like toString and equals, etc. So let me go ahead and create a test class. So here we can call it employee test, employee filter test, as we're going to filter the list of employees. So let's write our first test here. Okay, what are we going to name it? Of course, there are naming conventions and naming patterns for tests. You can also find them in our session, but I will choose one that is when plus the state, then plus the expected behavior. So we can say when the list contains employees of all age partitions, then, and the expected behavior, then return employees 18 and above. So this is the name for our test. We're going to structure our test in the arrange, act, assert, as Ahmed mentioned. In the arrange phase, we want to set up our data on which we're going to execute the test. I have already prepared the list here, so we don't have to type it all again. Let's just import the list class. So this is the list of all employees as per the Carta. You can find it here. Act is the section where we apply our logic on the data that we prepared. So we're going to assume that we have a function that's called filter employees 18 or 18 and above. That's going to work on our list. It's going to return a list that we will call filtered employees. Let's for now make it return null, this dummy method that's going to contain our production logic later. And in the assertion phase, we make certain that the expected behavior, that the outcome is equal to the expected behavior. So we're going to have a list of the expected employees. We can clearly see here that there are two employees we're going to expect to be in the outcome or in the list, in the filtered list. So let's just write them down here, and we're going to call it expected employees. So we just have to assert that the expected employees equal the filtered employees. So let's just assert equals the expected employees and the filtered employees. Now everything seems, there seems to be no compilation errors. We can run our test to see it fail. Okay, great. Our test works and it's a red bar. It gives us a red bar. We can move on to the next phase, the green phase, where we just want to write the minimal production code that will make our test go green. In this case, as you can see, the simplest thing we can, as you can see, we're asserting that this equals that. So we can simply return the expected list. As you can see, this is the minimal code I can write to make the test go green. We can run the test again, but this is a sort of faking it until we write the real code later. So this is the green phase. We go to the refactor phase. In the refactor phase, we should write the real actual code that's going to do the filtering. So here we can make a list that's going to contain our result. It's filtered employees. It's going to be an empty list initially, and then we're going to loop on all the employees, and if the current employee has age more than or equal 18, we could add it to the filtered employees list. So I'm trying to write the easiest code that I can think of to make the code go green as and refactored to as a production code. So here's a for loop that loops on the all employees and tests if the current employee under tests has age over 18 and adds it, and then we return this list. So we could run the test again. We can see that it works. Yes, we wrote the actual production code that worked for this, but as you can see, the code here is rather imperative. It's old style for loops. We can refactor this more into the Java streams. We could say return all employees. We could have a stream of all employees where we filter the employees who have age over than or equal 18 and collect it as a list. We can run our test again. Yes, and this is the use of tests. They help us when we refactor, because we now have a safety net that we didn't break anything. The code is much cleaner now. And finally, the integrate phase. We can now commit our code in the source, commit our code in the version store. We should write a message that's helpful and clear. There are a pattern for commit messages. We could choose the simplest one is where we just say we wrote test one, where we filter employees 18 or above on list of all ages. And we commit our code. Oh yes, we need to check the files and we commit the code. Okay, it's in a detached state. Okay, we'll just commit it now. Let's not let's forget about the Git issues that I found. Sorry. Okay, sorry for that. And Ahmed, please, you can go ahead now.
Okay, thank you so much, Khaled, for this quick demo. I hope this has shown our viewers how the TDD cycle actually works. So now that we are done with the demo, let's start talking about some TDD practices and tools that are useful for Java developers. And let's start with test automation frameworks. Now, people are going to wonder, are test automation frameworks a practice? So here I quote Ron Jeffries, okay? Ron, in his blog, has a blog post titled, "When Wouldn't I Use TDD?" And one of the situations where he says that he wouldn't practice TDD is when there's no decent testing tool falls readily to hand. Okay, and yeah, sometimes this happens. You're using some new programming language that doesn't yet have some good TDD tools. So you're left with two options, either implementing very primitive tests or having to invent the test framework from scratch. So this is the situation when TDD is going to be, very, very difficult to apply. And that's why when you have a good test automation framework, this is actually good for your TDD practice, because if you don't, this could be a reason why you wouldn't be using TDD. But let's not take this as an excuse. Very decent testing tools exist for most languages and frameworks you can think of. And Alan Davis, in his book 201 Principles of Software Development, in his software design principles, one of the principles he describes is that design should not reinvent the wheel. Okay, so when you are presented with a piece of software to develop, and you want to start delivering the behavior, okay, the actual features of the software, you want to be focusing on actually delivering value and not working on a TDD framework or a testing framework in order to practice TDD. So you don't want to reinvent the wheel. You don't want to reinvent tools unless they don't exist at all. So using a decent testing framework is going to be handy in your software development. Now, the most popular testing frameworks in Java are JUnit and TestNG. And I know most people are familiar with JUnit. However, you may want to have a look also at TestNG. It's got some really nice features that don't exist in JUnit. And I see in a lot of the courses that are taught by test automation engineers, they sometimes prefer TestNG over JUnit. So you've got both frameworks. JUnit is more popular, and I personally prefer JUnit. And the demo Khaled has shown us earlier was also developed using JUnit. However, know that TestNG is there. If you're about to start practicing TDD or test automation, you may want to compare both frameworks and choose the framework that is going to be a best fit for your project. Okay, so Khaled, is that your part or my part?
I think, Ahmed, you can still have this part.
Okay, so let's talk about test data generators. So when Khaled was doing the demo, he told you that he was going to use the arrange, act, assert to structure his tests. So how does that work? So in the arrange section of your test, this is where you initialize the objects and set the values of the data that is passed to the method that is going to be under test. So this is basically the section where you want to prepare your tests before they execute, or put your method under test, or unit under test, or software under test in the state that you want it to be before you start exercising the tests. In the act section, this is where you invoke your method or API, whatever, depends on the test level you're applying, with the parameters that you have arranged in the arrange section. And then in the assert section, you verify that the action that you have executed or exercised in the act section makes the software or whatever that is under test behaves as expected. So arrange, act, assert. So we use test data generators usually in the arrange section. Now, sometimes you can't think of test data to use, and you want some library to make up the test data for you. So for that, we recommend Java Faker. So this is a library that can generate that test data for you and if you check its documentation, you can tell it, oh, I want you to generate profile data, generate addresses, generate whatever, and it's really good at that, and it's a lot of help. However, you need to take care of something when you're using such a library. Now, this library is going to be generating the test data for you, but without you knowing beforehand or at compile time what the test data is. Now, in some cases, this can lead to your test becoming undeterministic, okay? And it can lead to your tests becoming flaky. So sometimes they pass and sometimes they fail, and you don't know why in some cases they're passing and why some cases they're failing. It could be because of some a conflict between your test data and something else. Let's say you're executing this against your web application, and the test data happens to match an ID of an HTML element, for example. This can cause some trouble. Okay, so just remember that when you're using this library, you want to use it in a way that will still keep your tests being deterministic. Okay, and I advise you to watch Kent Beck's videos on the test desiderata. These are 12 principles for writing automated tests, and one of these principles is that your tests should be deterministic. So just use this library with caution. Okay, so I guess Khaled, this part is yours, right?
Yes, Ahmed. Let me go ahead.
Okay, the floor is yours.
Also related to data provisioning, a reminder for the arrange section is where we prepare the data on which we're going to run the test. Say, for example, we have this application. The application contains a customer service. The customer service uses a repository to talk to the data store, for example, Postgres or whatever. Now, we want to have certain data in the database, like certain users who have certain profiles, etc., in the data store. Now, there are two ways to have this data in the database. We could write it in the beginning of our tests, as we did in the demo. As you can see, the list of employees, it was in the section, in the arrange section of the test itself. This might not be always appropriate because it's going to bloat the test itself. It's not reusable for other tests. Perhaps you could do something here or there, but it's not the best way to provide the data. Here comes these libraries. What most of these libraries do is they offset or separate the data initialization from your test code. So instead of initializing objects yourself and then persisting them to the database, you could write SQL scripts on which these libraries run and warm the database with such data. Here are examples of many libraries. Spring itself has the capability for this with the add SQL annotation. You could write a SQL command and have it run the SQL command before your test. There are also Flyway, Liquibase, and DBUnit. Some of them are database migration tools, which helps record changes to your database in terms of sets, having change sets cascade upon each other. They are also helpful with providing data by writing data in SQL scripts and having them run these SQL scripts before the tests to have them already in the database. We go on to the assertions phase, advanced assertions. As you know, the assertion phase is where we verify that the action is the expected behavior. We saw in the demo, we used a simple assert equals that's provided by JUnit. Almost all testing frameworks provide assertion methodologies, but sometimes they're not very advanced. They're not rich. They're pretty primitive. You're asserting two values that equal each other. There are other libraries, for example, AssertJ. AssertJ is much fluent and much richer than the out-of-the-box assert that comes with JUnit, for example. If you go to the website of AssertJ, you can find that it contains multiple modules, and these modules are helpful with different types of data. For example, collections. Others are helpful with date with dates with date elements where you verify certain items are come before or after, or has this minute of the hour or whatnot. As you can see, it contains many modules, as we saw, for Java, for Joda time, for Neo4j, for others for DB modules, etc. So I recommend you watch this. You could read about CertJ. And we also have Java Hamcrest. Java Hamcrest is just an honorable mention here in our case. It implements a subset of what we said, of the assertions that we said. You can find it in some of the projects written in Java, but we see AssertJ is very rich and fluent. Let's go ahead with test doubles. Okay, sometimes the test, the code under test that we're testing depends on an external dependency or an external system, for example, like a database or another system that we talked about, for example, APIs or whatnot. So how are we going to deal with this dependency? Having a real dependency here could induce some latency, could also induce some bugs, etc. What we care about is our code. We don't yet care about the integration with that dependency, etc. So we have to find a sort of replacement or something that now we call a test double. A test double that we can provide here to sort of decouple the real dependency and our test or our code. So there are 5 types of test doubles that are mentioned in XUnit Patterns book. There's the dummy. The dummy test double is just an initialization, an empty class. It has no logic, just a placeholder to fill the parameters list, etc. It's instead of sending null, for example. We have also a stub. A stub test double provides predefined responses to method calls during the test. So it only answers for certain methods that you provided answers for. So you tell it to, if it's called with this method, just return this, and that's it for the stub. The spy the spy is a little bit more advanced, as it records the interactions or spies on the interactions. For example, how many times a certain method was called. We have also mocks. Mocks are more advanced, as mocks also records the information, but it also records what parameters were sent for such methods. They have also expectations for the order of calling methods, have expectations for the inputs provided for the methods, and they can fail or throw exceptions if they say that if they see that the invocation order or the inputs are different from what they expect. So that's it for mocks. We've also fakes. Fakes are a simple implementation of a class or a dependency that has working behavior, but it's just symbols that it is not suitable for production. For example, here we have a in-memory storage instead of a real storage, but it has real behavior, unlike what we mentioned before. Where they have like canned answers. One of the most famous popular library for mocking is Mockito for the Java ecosystem. We also know about EasyMock. You might find it in other code bases, but I think that the majority goes with just Mockito. So some people ask, do we really need mocking? Some people argue that mocking tests the structure, as you saw here, that we provide certain answers for certain calls, method calls. So some people say that it's tied to the structure of code. Well, there are two schools here: the London school or the mockist school, where they have an outside-in approach. So when they're working at the outside layer, they yet don't have the inside layer, but the outside layer depends on the inside layer. So they have to come up with a mock for the inside layer so that they can work on the outside. That's the mocking school, and the mocking school depends heavily on mocks and the Mockito framework and other frameworks, as he said. The other school, the London school, or the Fakers school, or perhaps the Chicago school. Sorry, the other school is the Chicago school. It has an inside-out approach. They start by building the innermost layers, and since they have the innermost layer built, the layer outside of it can depend on the object. As for external dependencies, they also use fakes. So the Chicago school argues that we don't need mocks, we can use fakes, simple fakes written in Java without even the help of tools and libraries. But we present both schools, and you can choose whichever one works with you. If you're going to work with the London school or the mockist school, you're going to need the tools and the test doubles that we mentioned earlier. And we go for the integration testing and beyond. So as Ahmed mentioned, there are different levels for tests. And there's a common misconception about TDD that is just for unit testing. Well, TDD can be used for different levels of tests, and we have different level of tests because our system depends on external boundaries, and we have external systems that depend on our system. So having this what we call test boundaries helps us define the scope of the tests. What are we going to test? Do you have isolated tests, to have correct tests, etc.? So as Ahmed mentioned, the integration tests, we test the adapters that call external dependencies, for example, calling databases or other systems, and we also test the adapters for systems that call us, for example, here are controllers. The next type is through API tests, where we test everything from the controller or from the API onward, and the end-to-end tests, which contains the client. For example, here is a browser. A browser is as the client. The test starts there. So we said here that, for example, in integration tests, we're going to include tests for the adapters for the outer dependencies or external dependencies. So how are we going to test this? How am I, for example, going to test my code against the database? Well, one of the solutions to this is I could have a real database management server of the type that I'm using in production, of the real type. I could have it on my development machine, and then have an integration between the tests and that real database server on my machine. I could also have that database server or other system. I could have it running on the cloud somewhere and test against it. But as you can see, it requires a lot of work to have these systems up and running on my local machine or having on the cloud, etc. They require a lot of time, a lot of configuration, many things that can go wrong. That sometimes can be slow to run. So how can I do this? Do I depend on other fakers, for example, an in-memory database? Well, an in-memory database is a lot cheaper and a lot faster, but it's just a mimic of the real database. When I test my code against an outside system, I want to be as close to the real system that I'm using when I run my test. So what is the sweet spot here? Here comes test containers. Test containers are lightweight open source frameworks that provide throwaway instances of systems or of dependencies. So test containers are open source frameworks that provide lightweight instances, for example, of databases or of message brokers, of web browsers, etc. Using databases or of anything that could run in a container. Anything that could run in a Docker container can be run as a test container. So using test containers helps with the accuracy as we're running on exact real systems, with the speed, with the cost, etc. Here are some examples of the modules you could have out of the box with test containers. You could run against MongoDB or other brokers and systems. You can also refer to Riyadh Java users group session about test containers, and Tech Cafe's test containers, where we presented test containers in more detail and had a demo, but in Arabic. Finally, the last section for me is talking about API tests. API tests running API or calling an API. Well, Spring provides this capability through the REST template in Spring, as we know, but the REST template in Spring is just a REST client implementation. It knows how to call an endpoint and it returns the payload or body, etc. We also have in Spring something else that's called mock MVC. Okay, but the mock MVC only calls the APIs, but mocks the servlets. It mocks everything after the API. So it doesn't really call the servers or the servlet or the service. It doesn't call the OSI stack. It's just a tool for testing Spring MVC controllers by simulating HTTP requests. If we go to REST Assured is a library to test through APIs, tests for endpoints. So it contains a REST client and allows API tests to be written using the GWT formation. Here, for example, on the REST Assured website, they have a call. So when we get this API, we assert that the returned status code is such and such, and the body contains such and such. So REST Assured is a lot more fluent. It allows us to use the GWT notation. And Ahmed, I think you can continue from here.
Yeah, I guess that's my part. Okay, so I'll take over now. Okay, so let's talk about mutation testing. So going back to Tech Cafe's TDD cycle, we're now going to be talking about the inner circle, okay, and specifically the measures. So how do you know that you have written good tests? So the best way or the best measure, or let's not use the word best, let's use the word recommended, okay? Practice you can use to measure the quality of your tests is mutation testing or the mutation score. So what's mutation testing all about? It's a software design technique used to assess the effectiveness of a set of test cases by introducing small deliberate changes, which are also known as mutations, into the source code. So basically what that does is that some mutation testing library makes changes to your production code and runs the tests. Now, these mutations alter the code in simple ways, such as changing an operator or a variable, introducing small faults like replacing a plus with a minus, or changing variables, values, etc. And they run the tests, and they see if the tests are going to pass or fail. So if you make changes to the production code and the tests still pass, this is something that requires your attention. Okay, it means that there is probably something wrong with your tests because they were not able to detect the changes that have been done to your production code. Of course, if the tests fail, this could be a good indication that, yeah, you've done some changes that changed the behavior of your code, and the tests were able to detect that. So, what libraries do we recommend for mutation testing in Java? We recommend PyTests, okay, or PIT for short. It is a state-of-the-art mutation testing system providing gold standard test coverage for Java and the JVM, okay? And so we recommend this tool for you if you're going to be doing mutation testing. And we do recommend that you do mutation testing, okay? And if you go to our Tech Cafe podcast on YouTube, there is a session I've done that is TDD anti-patterns. And one of the anti-patterns I mentioned is not doing mutation testing. So mutation testing, I believe, is a practice that every software development team should do if they are writing tests using a test-first approach in order to be able to measure the quality of their tests. Another measure is code coverage. More widely used, however, it has its drawbacks. So let's first describe what code coverage is. So it's a software metric used in software testing to assess the extent to which the source code of a program has been executed by a set of test cases. So it basically measures the percentage of code lines, statements, branches that have been exercised by the tests compared to the total line statements or branches you have in a code, and you get a percentage. Okay, now the higher the percentage, the better your tests are. However, it's not always an accurate indicator that your tests are of good quality. So we would recommend that you use the mutation score as your primary metric and complement it with code coverage. One of the tools we recommend, and I think is one of the most popular tools used in Java, is Japuku. It's a very powerful code coverage tool, which I've personally used, Khaled has used, and we recommend that you use it for measuring code coverage. Now, there is a lot of controversy and criticism towards code coverage. And this can give the impression that it's not at all useful and let's just only depend on the mutation score. However, in an interesting discussion that I had with Paige Watson in one of our episodes on Tech Cafe, we recommended using code coverage to measure the quality of your characterization tests or your pinning tests. Now, when you are dealing with legacy code, as Michael Feathers describes, is basically code without tests. So the first thing you would want to do in order to improve this legacy code is first write a suite of tests. Now, we call these tests characterization tests or pinning tests because they test the behavior, the actual behavior or the current behavior of the code. Okay. Now, how do you know that the pinning tests you've written have covered or are good enough for that legacy code? One of the techniques or the metrics you can use is code coverage, because if you have high coverage with this legacy code, it's probably a good indicator that you have covered most of the cases in that code. Take care that pinning tests are also meant to discover what the code does. Okay, so if you want to make sure that you've explored all that can be explored, code coverage could be a good tool for that. So we are done explaining the practices and the recommended tools. So you can know all you want on the practices, but if you don't have good tools that will help you actually execute and exercise the practices, you may end up not doing the practices at all in test-driven development. So I quote Winston Churchill, give us the tools and we will finish the job. We have given you many tools that you can use in Java when practicing TDD, and we hope that these tools will make your job a little bit easier and will make your TDD practice and experience much more fun and fruitful. Okay, so I think we're done. We're going to keep this one more thing to after the Q&A session. So Mu'adh, I think the floor is all yours now. Let's take some questions, and then we will conclude the session with the one more thing we want to mention at the end.
Yeah, sure. Thank you so much, guys. It's been really an incredible and informative session. Uh, so we have here a couple of questions saying that first question we can say that when and how to embrace TDD and how to convince my team. If my team is not doing TDD first, so how can we make it first approach, and how can we like change the mindset and embrace it within our team members?
That's a very good question, Muad. Thank you for asking this question. Now, I have something prepared for you to answer. So you can check this article I wrote in 2023 on LinkedIn titled The TDD Adoption Plan. Now, in this article, I describe an adoption plan for test-driven development. It is a 8-phase plan with a very important prerequisite. So before you start this adoption plan, I recommend that you read about clean code, refactoring to patterns, design patterns, and extreme programming, because you will need all of that knowledge when you're practicing TDD, especially at the refactor phase. So first, learn about code smells and how to refactor them, and how to apply good design using design patterns, and then start learning TDD. Now, you will want to start with learning the basics, and these are the recommended resources for learning the basics. I think I may need to zoom in a little bit. Yeah, this should be good enough. So test-driven development, by example, is a must-read by Ken Beck, old as gold. And one more book that is not mentioned here is Jeff Langer's latest book. I highly recommend that book as well. So yeah, so you need to first start with the basics. Now, the basics should be technology agnostic, okay? Now, once you've learned about the basics, start learning about the technologies, okay? And this should be similar to what we have described during our last section in this presentation. So we first mentioned the practices. You should be learning this from the first phase, and then learn about the tools that you can use in each practice using your preferred technology. Then learn about the anti-patterns, and I recommend our video on Tech Cafe. Now, next step is you start practicing on katas. Now, never start practicing on real projects, okay? Because when you're still learning, this can mess up things in a real project and can end up, with the team not practicing TDD at all, okay? So you need to first start with building a little bit of muscle on TDD, but on coding katas. And I recommend that each team do a 1 hour kata every week or every sprint to practice TDD and other extreme programming practices. Now start with greenfield projects, then start applying katas on legacy code and brownfield projects, because this is going to teach you how to write pinning tests, characterization tests, approval tests, or test commit revert, which are the kind of test first approaches that you will be applying on legacy code bases. And then spike TDD implementation in a real project, and then start implementing TDD in a real project. This is our recommended adoption plan. There is another adoption methodology, but this is for more, towards projects, okay? It is recommended by Valentina Kupasht, and you can check her video on her channel. So this is our recipe for adopting TDD. Now, I move to the second part of your question. How do you convince the team to do TDD? I think you need to start with the why, okay? So you need to explain to the team why TDD is beneficial, okay? And you can use the slides we've presented for that. So if you tell them it promises faster delivery, better quality, better collaboration, ease of change, etc., these promises should encourage the team to at least try it out. Another way to convince the team is to walk the talk, okay? And that is why we're recommending that you practice TDD on katas. When people actually try it out, but without the stress of doing it in a real project, they will feel confident applying it in a real project, okay? So this is our formula. First of all, explain the benefits and the return on investment, and then walk the talk on katas. This is our approach, and Allahu A'lam.
Yeah, thank you so much. Yeah, sounds good. Sounds good, really. So for the like, don't you think that it's a bit long journey for the team and for the members to embrace these steps? So is there any like fast track journey or something like this?
Well, how fast the team is going to go is uh, not only related to how many steps or phases you have in the adoption plan. If the team does that on a daily basis, like an hour or two every day, then perhaps the plan can go a little bit faster. If people are not comfortable with reading books, they can attend workshops, they can listen to audiobooks, they can watch courses and videos. So I'm not with taking steps out of the adoption plan, but I think that if people put in more time in the adoption plan, and perhaps instead of reading they can listen or watch, maybe the plan is going to move a little bit faster. By the way, this is a plan that we have actually exercised on ourselves and with our teams, okay? So the reason why we are proposing this plan is that it is a plan that we've tested and we've tried and we know it works. If there is a shorter plan, I would love to learn about it. I mean, the shorter the better, as long as it delivers the same value.
Yeah, thank you so much. This will bring an immediate question regarding maybe for senior engineers or maybe experienced engineers that maybe these steps like sound easy for them, or maybe they would be like straightforward going or already practicing most of these steps maybe. But how about the juniors on or the new buys or the newbies or the new joiners? How can we, like, if they are not doing this in their past projects and they are joining our team, and my team, for example, they are already ahead of doing TDDs and these practices. So for them,
Yeah.
maybe it's very difficult to cope with the current implementations.
That's why we recommend collaborative programming. If the team is working in solo mode, then you will have some members of the team doing TDD and others not, or some people that are fast and some others are slow because of the learning curve. That is why we recommend collaborative programming. If I'm a senior developer who is well versed with TDD and I'm pairing with a junior developer, and the junior developer is observing how I practice and is taking over the keyboard or after 10 minutes or whatever the time interval that you set for exchanging the pairs, then the learning is going to be much quicker and the pace is going to be almost constant. And if the team does mob programming, this is even better because all of the team is going to be learning from the senior members at the same time. And I've practiced pair programming in almost every project I've worked in. I've practiced mob programming as well in a couple of teams. And believe me, forget about the project management mindset that you've got 10 people working on the same task, then we are burning man days very quickly and the team is actually slower. As a matter of fact, no, you move much quicker, especially when the learning curve is high when you're doing collaborative programming. So I recommend collaborative programming when you have, different levels of experience or expertise or mastery in the team in a certain practice. It will definitely speed up things.
Yeah, thank you so much. So going, uh, there's another question by brother Abdullah Ahmed. I think the question, I think you already guys answered it, but no problem. Let's take it quickly. How to answer if someone is saying that it doesn't really matter writing the tests after finishing up the feature, then we use the TDD after, or we use the TDD first, or we do the tests later. So how to
Yeah.
convince?
Okay, that's a really good question, and thank you, Abdullah, for this question. Okay, now we've partially answered this question during our presentation by presenting the anti-patterns of test loss development. Okay, however, there's this very nice book which I recommend reading by Amr Samadisi. It's called Agile Adoption Patterns. And in the chapter where Amr talks about developer tests, he actually talks about test loss approach as a, I would not say a valid approach, but as a fact of life. I mean, some developers will still practice test loss development. Okay, it's not a TDD pattern because TDD is test first, okay? But writing tests is better than not writing tests at all, okay? So I recommend that if you want to learn about the disadvantages of test loss development, I recommend that you read about it from our slides and from the article that we have referenced. There's also one more thing. The problem with writing tests lost is that you lose the real benefit from TDD, and that is producing good designs. Okay, because you've written the code and you're very happy with the code, you're only going to be worried about testing the code and not actually improving the structure of the code after you've written the tests. So you lose that when you're doing test loss. TDD helps you write good design and evolve the design with every cycle or every test. You lose that with the test loss approach. So yeah, there you have it. So read about why test loss development is bad from Tim Oettinger and Jeff Langer's article, and know that you lose the main benefit of test-driven development, and that is producing incremental and evolutionary designs.
Ahmed, if I may add to your answer, that writing tests first. So, what is a test? A test is the requirements written in code. So, starting with the requirements helps you go to the appropriate implementation. It helps you to write exactly as much code as needed to satisfy or fulfill that piece of requirements. But going through writing the code first, you're going to write many things. You have many things to write at one hand. You have all the requirements you're going to write an answer for. But writing test lists, going through this test list, going through the TDD patterns and TDD cycle that we mentioned earlier, helps you segment these requirements into little segments and then attacking each one and writing enough code for it. So I still do recommend writing tests first.
Very well said, Khaled. And yeah, there's a design principle called YAGNI. You aren't going to need it, or you ain't going to need it. So yeah, when you're not doing TDD or test first approaches, you will violate this. You will violate this principle because the tests let you only write code to satisfy the behavior that is going to be tested by the tests, okay, and not anything else. So yeah, you're absolutely right, Khaled. Thank you very much.
Yeah, thank you so much. Yeah, I think what you said, guys, is really absolutely true. Personally, I practiced both of them, both of those approaches. There was an incident that I was writing some of the requirements before and after. I mean, practicing test before and after. I observed that writing before, as Khalid said, it's really helping you to focus on that segment of code and that part of requirements, and also it will help you to design, because once I started writing it before, then I realized that I cannot test this piece of code. So I had to redesign my class and my functions. Then I was able to do my testing properly. Yeah, I think it's really really good.
This is a very good point, because if if your code is hard to test, then it is instantly legacy code. And it's funny that this is code that you've just written, and it's legacy code and it's fresh code. So yeah, indeed, when you're doing TDD, you write testable code, and this is something that is very very beneficial. Yeah, you're absolutely right, Matt. Thank you for sharing that.
Yeah, thank you so much. So I think Brother Masood was asking about some of the resources. I think Khalid already posted in the chat about some of the resources, some of the facts. So let's go for Abdul. For a web application, which test you should pick? Do you write the one on the controller layer or the service layer or the repository layer, for example? So which one to start with? That's a really good question.
Yeah, it's a really good question. So regarding Mus'ad's question, say in Saudi, Abshir, we will post these references in a comment after the session. Okay, regarding I think it's Abdul. So let's say Abdullah. Okay, now Khalid has mentioned the TDD schools or the schools of TDD. Okay, so you've got the London school, which is the outside in approach. So in that school, you start with the controllers, okay, and then you move your way down to the core of your application. Okay, and this is also known as the Mockest school because obviously the outer layer of your application depends on the inner layers of your application. So you always have to mock these parts of the application which you are dependent on, which have not yet been implemented. So this is the first approach. The other school of TDD, which is more popular and more recommended, is the Chicago school or the classicist school, or also known as the uh, inside out approach. This is where you start with either your service layer or your domain layer. Okay. And as I've said, it's an inside out approach, and it doesn't make any use of mocks. It can make use of fakes. Okay. And yeah, but of course, because you're building inside out, so basically every time you move to the upper layers, the bottom layers or the inside layers have already been implemented. So you can just write component tests against those. So yeah, you've got both approaches. Choose the approach which. And the funny thing is that though the classicist school is the most recommended, many of the teams that we work with practice the London school instead, because most people think outside in. Okay, they like starting with the APIs, the REST controllers or whatever, and then they build the inner layers. This is usually how people work, so they find that the London school is more appropriate to their approach. However, I would recommend you try the Chicago school. If you're dealing with an application that has a lot of business logic and business rules, it would make sense that you first start with those and then build the outer layers, because the outer layers are basically just interfaces to this to your business layer.
Yeah, yeah, I think so. That sounds really good. I think the outer layer is the I think what it's very close to the test after, because when we test after, we start with the service layer. I think most of the times we start with the service layer, then we go for the integration layers. So yeah, sounds
You're right. When you're not practicing TDD, but you have test automation, usually test automation falls in the hands of the testing team. Okay, and the testing team do test last, and they like executing their tests either against the UI or the APIs. Okay, and this is basically an outside in approach. Okay, and it's end to end or system tests. This is not the approach we recommend, of course. It's not agile at all. Many people use test automation and agile testing interchangeably as if they mean the same thing. They definitely don't. Totally different games. But yeah, you're absolutely right. The outside in approach sounds like the kind of approach you will get when you are doing the classic test automation. Yeah.
yeah. So the next question maybe addressing to Khalid. We need some demos for test mutations. Mutations, Khalid.
I can refer to the Tech Cafe session with Daniel Mocha. Sorry, what's his name? Daniel Mocha.
Yeah,
Yes.
yeah. But this is in .NET, not in Java.
Yes, yes, true.
That's why we need something special for Khalid.
Yeah, yeah.
Thank you, Maad. Maybe with Ahmed and you, we can coordinate another session where we reiterate on the theory for mutation tests and also have a little demo. I think that's very possible.
Yeah, sure, sure. Thank you so much. I think we don't have any further questions. If you'd like,
Okay,
guys.
so we can move to the one more thing part, if you don't mind, Muad.
Sure, sure.
So, yeah, is my screen sharing? Yep.
Yes, it is.
Okay, so regarding the mutation testing questions, so yeah, we can plan a session for that. Or if you don't want to wait until we do our session, Khalid and I do TDD workshops, and here we're showing pictures from a workshop that we have done previously with a very talented group of software engineers that included mobile developers, backend developers, and even software testers. So this was a really good session. We also do these workshops online, and these are screenshots from some of the online workshops that we have done. Check out our website, the corporate or individual workshops pages. You'll find our two courses, the Test Driven Development Fundamentals and the Advanced Test Driven Development Workshop. We teach mutation testing in the Advanced Workshop. So if you can't wait till we do the coming session, either on Riyadh Jug or on Tech Cafe, you can definitely book a dedicated workshop for that. We also have this agile tool called the TDD cards. These are cards that basically explain the practices under each of the circles in Tech Cafe's TDD circle. This is a picture of the card deck. So it's got 50 plus cards. Each card under every phase explains the recommended practices and patterns that you can use in your TDD practice. And you can use these cards for all sorts of things. We do have a dedicated card in the card deck that explains the different ways you can use the cards in. Okay, so one of the ways we like using the cards is measuring the maturity of the TDD practice that you have. So we pick up every card on the card deck, we explain the practice or the pattern, and we see if the team is practicing it or not. And then we calculate a score, and based on that score, we tell the maturity level of the TDD practice for that team. We've done an episode on the Tech Cafe podcast showing how to practice TDD with just a very, very small subset of the card deck. So you can just scan the QR right here and watch these videos. And it has been exercised against the same kata that we've used in today's session. And we offered 3 free workshops for 3 teams as a special gift to the viewers of Riyadh Jug and our viewers on Tech Cafe. So 3 free workshops using the cards. So if you're interested, just scan the QR, fill in the form, we'll contact you, and we can start doing the workshop whenever that is suitable for you. So that's it. This is all that we have. Muad, thank you very much. I know you will be concluding the session as well, but from my side and on behalf of Khalid, thank you so much for organizing this on the Riyadh Jug and on your channel. And congratulations. I think the session was successful, and we've enjoyed it a lot. And we hope to do more sessions with you. And keep on going. You have a wonderful channel and a wonderful community and a wonderful group. And it's a pleasure that we are part of your effort in promoting Java and Java technologies in Riyadh and perhaps the whole of the Gulf region.
Thank you so much, guys. Really wonderful session by you guys. I was really impressed by the amount of information. It's really amazing. Even the series of the presentations and the demos. Khalid, Ahmed, thank you so much for accepting our invitation. And we promise you, inshallah, in the future, we're looking forward also to, having more sessions with you guys and more partnerships with the Cafe as well. Thank you so much.
Inshallah.
Thank you,
Inshallah. Thank
Mark.
you so much.
Inshallah.
Thank you so much. See you guys. Assalamu
Bye
alaikum.
bye. Alaikum salam. Bye bye.
Can you end the